Part 1 of the test will be no calculator. So make sure you practice this where you're just doing it with your head, not your calculator. So the first problem asks us to find the vertex. And we know that when it's in standard form, that the vertex is going to be negative b over 2a. That's going to be our h, or our x-coordinate. And we know that our k will be putting back in that h we find into our equation. So in our problem, a is negative 3 and b is 6. And if you notice, there is no constant. There's no number by itself, so c is 0. So our b will be 6, and our a will be negative 3, and I get 1. So now I'm going to put back 1 into my equation. So I'm going to say f at 1. So wherever there's an x, I'll put a 1. And I'll get negative 3 plus 6 is equal to 3. So my vertex will be 1, 3. The next question asks, what is the equation for the line of symmetry? We know that the line of symmetry is always right to the vertex, so it's x is equal to h. And we already found what h is. H is always going to be my x-coordinate for my vertex. I have h for my x-coordinate, and I have k as my y-coordinate. So in our case, our line of symmetry will be x equals 1. Our next question asks us to find the vertex of the function. This time it's in vertex form. So x minus h squared times a plus k is equal to y. So we know that our vertex is hk. So we look here and here. This is going to be h and this is going to be k. And remember the trick I taught you, h lies, k tells the truth. Is kind of an easy way to remember it. So my vertex will be negative 4, 8. And is it a minimum or a maximum? Well, minimum and maximum should be easy because all we need to look is our a. And the a is the number in front of the squared expression. In this case, it's 0.375. When it's positive, if a is greater than 0, so it's positive, positive people like to smile. So that means our parabola points upward, which would mean that our vertex would be the lowest point on the graph, and that would be a minimum. Our next equation asks us to find the center of a circle, and they give it to us in standard form. And we know that standard form is r squared is equal to x minus h squared plus y minus k squared. Now, hk is my center. This is different than quadratics. On this one, you have to remember that h and k are both liars. So whatever you see is going to be the opposite. So in our case, our center is going to be negative 5, 2. Now, our r, we know this is r squared. So our r will be 10. And we know that because we know that a radius is a distance, and so it's always going to be positive. Our next problem gives us a function in vertex form, and it says, will it open upward or downward? We already talked about this. We said that a, the number in front of the square, tells us whether it's going to open upward or downward. So if a is positive, it's going to go upward, and if a is negative, it's going to go downward. Our a is 3/4, which is 0.75, which is positive. So positive people smile, so it's going to open upward. Would it be narrower or wider than the basic function? Now, we learned this in the last section, just different words are being used. Okay? We're not looking at the negative or the positive of that a. Instead, we're looking at the number itself. So if a is greater than 1, it's going to be narrower. And if a is between 0 and 1, a fraction basically between 0 and 1, or a decimal between 0 and 1, then it's going to be wider. Notice it does not matter if they're negative or not. I'm not looking at whether it's negative. I'm looking at the absolute value of that A value. So in our case, we have 3/4, and 3/4 is between 0 and 1, so we know it's going to be wider. Problem 5 tells us, oh, we're going to use a quadratic formula to solve this. And it asks us, what would A, B, and C be? Well, you can never use the quadratic formula unless it's equal to 0. So before you do anything, move over that minus 12 or negative 12 to the other side. So I added 12 to both sides. Okay? Now, step 2, always make sure that you're in standard form. So easy to be tricked. So notice I moved the square first, the x second, and then the constant third. And now I can easily see that my A is 5, my B is 3, and my C is 12. I don't remember the test, but it could be a tricky one like that, so make sure you're careful whenever you're dealing with quadratic formula. The next problem asks you to solve the quadratic formula, and I want to see the quadratic formula. I want to make sure you memorize it. So if you have not memorized it, an easy way to remember it is a story. A negative boy couldn't make up his mind if he should go to this really radical party. Because he was square, he missed out on meeting 4 awesome chicks. And the party was all over by 2 a.m. His name was Xavier, too, in case you're wondering. Now, we have this written. We have to make sure we plug A, B, and C correctly. We just did it, so let's make sure we do the same thing. I'm going to add 4 to both sides. And I'm going to get 3x squared plus x plus 4 is equal to 0. So A is 3, B is 1, and C is 4. I'm going to replace them in my quadratic formula. Notice, I always put little parentheses when I'm evaluating for A, B, and C, because if not, I screw up the negatives and positives. So try that as a tip. Next, I always do the discriminant, which is the stuff under the radical. So if I do that, I can simplify that as 1 minus 48. Okay, so I know that I'm going to end up with a negative because 1 minus 48 is negative 47. Now this problem asks us to write it in exact form because I know you don't have a calculator. So all you need to do is write -1 plus, and then let's make this be a complex number. So we know this could be square root of 47i all over 6. And then let's do the other side, -1 minus square root of 47i all over 6. Notice I didn't have to figure it out mathematically and figure out exactly what it was. You don't have a calculator. It'd be really hard to do. This is fine. Just leave it like that. That's good enough for me. Let's look at our next problem. This one asks us for the discriminant. We know that the discriminant is the stuff under the radical. So when you have the quadratic formula, stuff under the radical, we call that the radicand, b squared minus 4ac, this is the discriminant. We need to figure out what a, b, and c are. And the only way we can do that is by making our equation equal to 0. So I added 3x to both sides, and I can see that a is 4, b is 8, and c is 4. And I can evaluate my expression now for those variable values. And I end up with 64 minus 64. My discriminant is 0. And it asks me, how many real solutions are there? Well, we know that when our discriminant is 0, we're only going to have one real solution. So let's just go over those rules really quickly. Our discriminant, if it's equal to 0, we're going to have one real solution. If it's less than 0, we're going to have no real solutions. And if it's greater than 0, we're going to have 2 real solutions. Okay? So be ready for any variation on that. Our next problem wants us to graph a quadratic. Okay, so what I always started with is my vertex. I know my vertex is going to be 5, 6, right? Because it's in vertex form. That's my vertex. And I know this is going to be my line of symmetry, so I just draw myself a little center line to remind me of that, okay? And you can label it if you want, that's fine. Is it going to be going up or downward? And the way I know that is by looking at the A. The A tells me that it's negative. And since I have a negative A, it's going to be pointing downward. Typically, I kind of lightly sketch that in. The next thing I'm going to want are the intercepts, right? Those x-intercepts, those solutions. So that's going to be a problem. I know at the x-intercept, y is equal to 0. So I set my y, my f of x, my y equal to 0. And since I'm in vertex form, I can just use my square property. So I'm going to say minus 6 on both sides. And then I'm going to divide both sides by negative 3. And I'm going to take the square root of both sides. And I'm going to see that x is equal to 5 plus or minus the square root of 2. Okay. Now, the one I'm going to give you without the calculator will be a little easier, but we know the square root of 2 is about 1.4. So I'm just going to sketch those in. So I'm getting a good idea what this is looking like, right? And maybe I want one more point on each side. So I'm just going to pick, what about when my equation is, I have an x of 6. So if I have an x of 6, that'll be negative 3 times 6 minus 1 is 1 squared plus 6. So it's going to be negative 3 plus 6. That's going to be 3. So I'm going to have 6 and then 3. And then using symmetry, I can put 1 on the other side too. Now the next part of our test, a graphing calculator is allowed. And so you're welcome to learn all the features on your graphing calculator. Number 9, though, asks me to solve by completing the square. So I need to see you complete the square. I do not want just an answer without you completing the square. That's why I say solve by completing the square. So the steps for completing the square are, first, if A is not 1, you're going to need to divide through by A on both sides. But in our case, A is 1, so we're fine. Next, I want to make sure that my equation is in standard form, and I'm going to add the C value to both sides. Because I want to end up with ax squared plus bx equals negative c, and have a equal to 1. So I get x squared plus 14x is equal to 38. Now here's the completing the square part. You must show me that you are going to add b over 2 squared to both sides. In our case, our b is 14. So we're adding 49 to both sides. But what we always will end up getting, if we add 49 to both sides, your left side will always be a perfect square. It will always have the variable first, and then it will always have b over 2 value as my second term in my binomial. So now I'm going to use the square root property to solve. I'll take the square root of both sides. And I have to remember that I get a plus or a minus on the side with the constant. So my answer will be x is equal to negative 2 plus or minus the square root of 87. And you can leave it just like this, because I asked you to leave it in exact form. That's fine with me. If it says exact form, you can leave it as with the radical. If it says decimal, then use your calculator and put it in your calculator and see what the answer is. Our next problem says solve on your graphing calculator. And it tells you to round to 2 decimal places. So get those graphing calculators out. So I've entered my equation into my grapher. There are different methods to do this. The one I've shown you in class and on videos has been the intersect method. So in this method, you must enter y2 equal to 0. You must have two equations to see where they intersect. And then you can hit graph. And you can see the parabola. And you can see the two solutions, those two x-intercepts. So we'll hit second trace 5. We will always hit 3 enters. 1, 2, 3. If your calculator is lagging, wait till it shows the graph and starts asking you for prompts before you hit enter, enter, enter. So my first 0 is going to be 2.3944487, but it told me to round to 2 decimals. So if I round to 2 decimals, it'll be 2.39. Let's find that second 0, that second solution. So I'm going to say again, second trace 5. But before I hit enter, 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 I need to move my cursor closer to that x-intercept. So the way I do it is I use my left or my right arrow, always left or right, because that makes it travel along the function. And I just move it anywhere closer. Do you see my little spider? He's blinking closer to that right intercept. So I'll say enter, enter, enter. And my second intercept will be 9.61. We really should put a little approximate because we're rounding to 2 decimals. Our next problem says, given the function, and it gives me a standard form for a circle. We know that a standard form for a circle is the quantity x minus h all squared plus the quantity y minus k all squared, and that's equal to the radius squared, where our center is hk. Okay? So it says, what is the radius? So we don't care about h, we don't care about k, all we're looking at is the radius. So in our case, r squared is equal to 5. We can take the square root of both sides. I know I get plus or minus the square root of 5. But we know that radius, it's the distance from the center of the circle to the outside of the circle. And so we know a distance is always positive. So our radius will only be the positive square root of 5. And you may leave it like this because it said leave it in radical form. If it asks you to round it up in decimal, then you just put it in your calculator and round it. Number 12 asks you to find the equation in vertex form of the quadratic, oh, and I wrote it twice, in vertex form that passes through a point with a vertex of 4, 5. So the vertex form is the big hint. We know vertex form is a times x minus h squared plus k is equal to y. And we know, be careful, our vertex is the h and the k, and the point will just be the x and the y. So maybe label them before you start so you don't get them screwed up. So I'm going to replace my x and my y, 1 and negative 2. So x is 1 and y is negative 2. And I know I'm going to replace my h and my k with 4 and 5. By doing this, now I've created an equation that only has one variable, a. So I can solve for it. So we know that 1 minus 4 is negative 3. And we know negative 3 squared is 9. So 9a plus 5 is equal to negative 2. So now I'm going to solve for a. And I'm going to get a is equal to negative 7/9. But I'm not done. You must write the equation. And an equation needs to have an x and a y. So we're going to say what we started with at the very beginning. Our equation is in vertex form, and I'm going to replace a with negative 7/9. Notice I'm going to leave, oops, I lost that y. I'm going to leave x and y just as x and y. And I'm going to put in my vertex because the vertex is always the vertex. So I'm going to say minus 4 and plus 5. And this is my equation in vertex form. Number 13 asks you to write the equation in standard form. So this is a hint. When it says standard form, you know it's going to be at the end. It's going to look something like this. That's our standard form. And they're giving me these x-intercepts. So we know from the zero factor property that if they tell me that my solution is -5, you can think of it this way. You can say, well, if x equals -5, right? Then I know if it's a 0, I'd say x plus 5 equals 0. And the same thing with my other intercept. So if I were to add 7 to both sides, now I've got two factors, right? That would make 0. So I'm going to say x plus 5 and x plus 7. So I know using the zero factor property, those will give me those two intercepts. But I don't know about this multiplier in the front. That's what I'm going to need to solve for. Piece of cake, we have this. They told us that it passes through a point. So we have an x and a y. So in place of x, I'm going to put 1. And notice I do it twice because I use x twice. And in place of y, I'm going to put 12. That only leaves me a to solve for now. So I end up with a times 6 times 8 is equal to 12. So 48a is equal to 12. And a is equal to 12 48ths, and you're welcome to simplify it as 1/4. Just like before, we're going to do the same thing. This is not our answer. This just tells us what the a is. So we're going to write what our original problem was. So we're going to start back from the very beginning. A times our two factors that we found our zeros. And we said it was equal to y. Well, now we know what a is equal to. A is equal to 1/4. So we have our equation. The only thing is, if you want full credit, just go ahead and multiply it out so it's in standard form. So we can do this. We'll use our distribution. So I'm going to get x squared plus 12x plus 35. And I have a multiplier of 1/4. So I end up with 1/4 x squared plus 12 divided by 4 is 3x plus 35 over 4 is equal to y. And this is our equation in standard form. Number 14 wants me to solve the quadratic inequality. So when we're solving a quadratic inequality, we always want to move our variables on our left, and we want to have it equal to 0 on the right. The next we want to do is find those intercepts. So the way we find our intercepts is we use the quadratic formula, or we can use the zero factor property. So I'm going to try the zero factor property first. And I factored my quadratic, and I got 5x minus 3 times the quantity x plus 2. So I can find my zeros by setting each of those equal to 0. And I'll get x is equal to 3/5 and x is equal to -2. If I had used the quadratic formula, I would have gotten the same answers. So I draw myself a number line. And I put in my 2 zeros. All I need to do is look at my A. My A is positive. So I can see my parabola is going to be going up. So I can sketch that onto my graph. Now, you guys have a calculator too, so if you want, graph it and you'll see that's true. But we don't even need that. We can tell it just by the A. So now I want to look at my sign. Sign says greater than or equal. I know that greater than or equal or greater than, I'm looking for my values where my function is above the x-axis. If I have less than or equal or less than, I'm looking for below the x-axis. So mine is greater than or equal. So I'm looking for the portion of my function that goes above the x-axis. So this is going to be this region on the tails of my quadratic. So my last step is just to decide, am I going to include those zeros? And I look at the inequality sign. If it has an equal in it, so for example, greater than or equal or less than or equal, then you will include those endpoints. So it's going to be -∞ to -2 with a bracket in union with 3/5 to infinity. Now, a couple people have had questions on the homework, so I want to remind you, infinity always gets a parentheses. Our next problem is a word problem. So the steps we're learning to solve word problems, our first thing is we need to understand the problem. So we want to read it and think about what it's asking. The height in feet reached by a model rocket after t seconds is given by the function h of t is equal to negative 16t squared plus 200t. During what time interval did the rocket reach an altitude higher than 330 feet? So the first thing I do is I think to myself, what's it asking me? Well, it's asking me for a time interval. That's a good clue word, isn't it? An interval. And I can think what it's doing is a rocket's going up and down, right? And if I were to think about this on a graph, I'd say, wait, if I could make a graph to describe this problem. So the next thing I'm going to do is implement a plan. So I'm just going to do a kind of a quick sketch here. I know that the input is time, and the output is h of t, which is height. And I think I know what this looks like. If I were to see this, it would be going, well, it's going from the ground, and then it's going to go up, and then it's going to come down. So I can see it's parabolic. I also see that it's a square, so I know it's a quadratic. The next thing I'm going to do is going to implement a plan. When I read the question, it says, what interval did the rocket reach an altitude higher than 330 feet? And when I see the words like higher than, or at least, or more than, these kind of words make you realize that, oh, we're talking about an inequality. So if I were to make this equation and I were to set it greater than 330, then my output, because that's what this expression is equal to, would have to be greater than 330. So that would be the same thing as saying, well, if I have 330 on my graph, it's going to have to be these values. Okay, so I think I have a plan now. I'm going to solve my quadratic, and I'm going to see the interval in time, because that's what we're looking for, right? That my quadratic will be above 330. So my plan to solve a quadratic is I always use quadratic formula, or I use the zero factor property, or sometimes I use my calculator, right? But all of those require this to be equal to 0. So I'm going to subtract 330. Now, I could use the quadratic formula right now. I would say that A is equal to negative 16, B is equal to 200, and C is equal to negative 330. And so I found that my 2 times, using my quadratic formula, I found that my 2 times are going to be 1.96 and 10.54. But realize this is not the answer. We want the interval. We want to see what time is it above 330. So this will have to be an interval, and it gave us that clue word here, that if we put them on the number line, smallest one first, and then we sketch the shape of the quadratic, which will be down, because we know A is negative, right there. And we go back to our problem, and we ask ourselves, what inequality sign do we see? 1.96, comma, 10.54. And we'll be using parentheses because we see that it doesn't have the word equal with the inequality sign. So it's only going to be the values that are greater. It won't include the endpoints. And we have one more step. We always want to check our results. And that just means look at it and make sure that it makes sense. So for example, this is time, and time would have to be positive. Well, both of those values make sense. And doesn't it seem reasonable that the rocket could reach high in about 2 seconds, and then it would start falling, and it would be falling down again in about 11 seconds? Our next problem is a distance problem. So you can memorize the distance formula, Or that you can just realize that it's just the Pythagorean theorem, which is what I do. So to me, I just think to myself, well, if I were to plot this, this would be 6, -3. And the other one would be 12, -10. And I draw the triangle. And I say, this is 7 units, because distance is, it's always positive. And this is 6 units. And then I would just square both and take the square root, because that's what we know that hypotenuse would be equal to. And I'd get the square root of 85. But if you want to use the distance formula, you can. Use the same idea. It's exact same principle. That's where the distance formula comes from. So we just label our points, x and y, and we choose one to be 1 and one to be 2. It doesn't matter which one's which. And then we evaluate x1 for 6 and x2 for 12 and y1 for -3 and y2 for -10. So you're just finding the difference between those two values. And you would get, I'll bring it down here. Our problem told us to round to 2 decimals. So this would not be the answer, just square root of 85. We'll need to put it in our calculator. So let's get those calculators out. And let's just make sure we're all comfortable putting in the square root of a number. So I'm going to say second, and then I'm going to hit x squared. And that gives me the radical symbol, and then type it in and hit enter. And it should be 9.22 since we're rounding to 2 decimals. Now, I cleaned it up a little bit, but the next problem asks us to find the midpoint. So we can memorize the midpoint formula, or we can just realize that we're just averaging the x's and averaging the y's. Your choice. So if you're going to use a formula, you label the x and y of each point, and then you choose one to be 0.1 and one to be 0.2. Notice the ones go on both the x and the y. This means 0.1. And the 2's go in the subscript of both of these, because that's 0.2. And then we just evaluate our formula, and I get 0, -17.5. Next, find the equation in standard form of a circle with radius 7 and center -4, 0. We know that the equation for a circle in standard form is the quantity x minus h all squared plus the quantity y minus k all squared equals r squared. So we have our center, which is our h and our k. So we can replace h with -4 and k with 0. And we know our radius, r, is 7. So we're just going to evaluate this equation for those values. So I got the quantity x plus 4 all squared plus the quantity y minus 0 all squared equals 49. Or you can clean this up a little more and just remove that -0. We don't really need that, do we? I would accept either one. Now, our next problem is a rational exponent, which means a fraction for the exponent. And then raise it to its reciprocal. Because we know that 3/2 times 2/3, well, that would be 1. And that's the whole idea. We're trying to get it to the power of 1. So I get x minus 1 is equal to 8 to the 2/3. Now, you have a calculator. So if you're getting confused on these, let's show you how to do it in the calculator. So you would put into your calculator 8, and then you're going to raise it up. I put my exponent in parentheses because it's a fraction, so that it stays all up there. And then you can hit enter, and it will say 4. Okay? Another way you can think about it, if you don't want to use your calculator, is you realize that this means my base is my radicand, the bottom of my fraction is my root. Just like we said, the bottom of a flower, the roots appear there. And then the square is just an exponent that it's raised to. And you could write it like that, or you could write it like this. and put the power on the inside, your choice. But on this one, I think it's a little easier myself to deal with it on the outside. So the cube root of 8 is 2, and 2 squared is 4. We get the same answer. And then we just solve for x by adding 1 to both sides. And we get x is equal to 5. Whenever you're dealing with radicals or rationals, you must check your answer because you could have developed extraneous answers. These would be solutions that you did the procedure right, but you just have created a solution that's not really a solution. So here we go. We're going to put in a 5 for x. And we're going to get 4 raised to the 3/2 power, which once again, you can use your calculator, or you can say to yourself, this is the square root of 4, which is 2, raised to the 3rd power, which is 8. And this truly is our solution. If you do get an extraneous solution, you just cross it out. Sometimes both of them will be invalid. Sometimes one of them will be invalid. Sometimes, both of them will be valid. It just depends. Our next problem is going to be a rational equation, which means we have to make sure that the denominator never equals 0. So we always want to remove any values from our solution set that would create this. So in our example, a -11 would create a 0 over here, and a 3/2 would create a 0 over here. Sometimes I just jot them down. I'll put them over here on the side. I'll say x cannot equal. These are not in our domain. But you'll also discover these by checking your answer. So when you have a rational equation, the best thing to do is to get rid of the denominators. We don't like rational equations. People don't like fractions. And an easy way to do that is to just multiply both sides by the denominator's factors. So that will help. But in this case, it's even easier. When you have a proportion equal to a proportion, we have one fraction equal to another fraction, we can simply cross multiply. And when you cross multiply, you literally say the numerator of the left times the denominator of the right, and then you do the other side. And now I've removed the denominators, and this is much easier to solve. So I'll just distribute, and I've discovered that I have a quadratic. I like quadratics. I know how to solve them. Zero factor property, quadratic formula, or my calculator, but they have to be equal to 0. So I subtract x squared, and I'm going to go ahead and subtract 11x at the same time. I could do it in 2 steps. And now I'm going to use the zero factor property because I realize that I can factor this one really easily. And I get 5x is equal to 0, and x minus 4 is equal to 0. So my 2 answers will be 0 and 4. But whoa, you have to check, because for radicals and rational equations, you must check your answers. Sometimes you've done it correctly, but you've created extraneous solutions. Now, we already know that -11 and 3/2 are bad. They're bad, and they're not allowed in our domain. We did that before we started the problem. But let's just go ahead and check 0 and 4. So if I put in a 0, I do them one at a time, and I would get 0 divided by -3 and 0 divided by 11. And this is fine. You can have a 0 in the numerator. You just can't have it in the denominator. So this would be 0 equal to 0, and this is true. And if you're not convinced, put yourself the problem of the idea of the division and the way we thought of it growing up, where it's in the little divisor. And you can see that 0 times -3 would give me 0. So we are allowed to have a 0 in the numerator, just not the denominator. So x is equal to 0 is a solution. Now let's check x is equal to 4. So do repeat the same procedure. And I get 4 over 5 is equal to 12 over 15. And if I reduce 12 over 15, then I will get 4 over 5. And you can see that 4 is a solution. So both 0 and 4 are my answers. Our next problem asks us to solve a higher order power problem that's not quadratic, but to reduce it to a quadratic and to solve. And I will give you these keywords on the test, so don't worry. So what we want to have happen is we want our first term to have a square as the exponent. So I'm just going to write below it u squared. And we want our next term to be a u. So I write below it u. And then I write let u squared equal x to the 6th. And then I write let u equal x cubed, which makes sense because if I took the square root of u, then I would get the square root of x to the 6th would be x cubed. So that is quadratic, so this is okay. So now I've already set this up, and I'm just going to fill in the numbers that are coefficients in front of these. So what I've done is I've created this u quadratic, and I'm going to solve it. And you can use zero factor property, you can use quadratic formula, but you do need to show me work. So don't use a calculator, I'd like to see you do it. So I get u is equal to 8 and u is equal to 1. Okay, so I have to realize that I do not have the answer yet. So I'm going to keep going. I'm going to replace u with x cubed. And I've created two problems to solve. Now, we haven't done these in a while, but cubes, we're going to use the difference of cubes formula. Let's just review that. So I'm going to use the zero factor property. So I'm going to subtract 8. And then I'm going to use my difference of cubes factoring. And now I'm going to set each factor equal to 0. So this one's easy. X is equal to 2. To do the other side, I'm going to use the quadratic formula. I get -2 plus or minus 2 square root of 3i all over 2. You could use the decimal equivalent if you wanted to. And now I'm going to solve my other equation using factoring. Number 22, I want to make sure you can factor. So first, look for a greatest common factor. Well, 29 is prime, so I know there's not one. So I'm going to use whatever method I like to factor quadratic. One method that you might want to use is you say a times c, 180. And we want a factor pair that adds to be -29, that middle b term. All right, so we're looking for two numbers that multiply to be 180 and add to be 29. Okay? If you're having problems finding these, use your calculator. What you can do always is put it in your grapher as AC, so in our case it's 180, divided by X. And then if you hit second graph, it will give you all the factor pairs. So we're just going to start with 0. We're looking for a factor pair that adds to be -29. You can see all these are positive, so I'm going to go down. And I only stop and look at the ones that are whole numbers or integers. So -3 plus -60, that'd be -63. So -4 plus -45, that'd be -49, but I am getting in the right direction though. I don't stop at the ones that are decimals. Well, here we go, -9 and -20. When I multiply those, it gives me 180, and when I add them, I get -29. If you use this method, you divide by A, both sides, and you simplify. And if you're having problems with simplifying, use your calculator. So what you do is you enter in your fraction, so -9/12, and you hit math 1, enter, and it says -3/4. You do the same thing with -20 over 12. And I get -5/3. So if you're using this method, it's called bottoms up. You put the variable, which is x, at the front, and then you put both the factor pairs as your second terms. But you're not done. You have to remember, bottoms up. which means if you have a denominator, it needs to go in front of the first term. So it's going to become 4x minus 3, and the same thing here, 3x minus 5. And this is the bottoms-up method. They also teach us in our math lab. If you don't like this, there's also reverse FOIL, which is I love. That's my favorite method. Or you can do fake factoring. All those will work. Or if you have a method that you just love, but you kind of feel a little rough on it, Google it or send me an email and I will send you a video about it. And on the test, would I check my factoring? Yes. And the way I check is I use distribution or FOIL or box, whatever method you like. So this is 12x squared minus 20x minus 9x plus 15. And this, when we multiply it, we get our original problem, so we know we factored it correctly. Part B says, use your factoring with the zero factor property to solve this equation. I've already factored it. That was part A. And now I'm just going to set each factor equal to 0. For this problem, I'm going to require you to show me this because I'm telling you how to solve it. So I get x is equal to 3/4. And x is equal to 5/3. So I have two solutions. Our next problem says solve using any method. I'm going to use the square root property since it already comes in vertex form, and I'm going to divide both sides by 0.25. Since I have the square isolated, I can take the square root of both sides. Using the square root property, you have to remember when you take the square root of a number, you're going to say plus or minus. So my two equations that I need to set up are x minus 4 is equal to 6, and x minus 4 is equal to negative 6. And set those up so if you mess them up, you'll get at least partial credit. People, when they try to eyeball them, they make mistakes. So I'm going to add 4 to both sides, and I get x is equal to negative 2, and x is equal to 4. And I could check each of these by putting them back into the original problem. So let's do that. So first I'm going to check x is equal to 10, and this checks. So next I'm going to check x is equal to negative 2, and this also checks. So that I know that I have two solutions. Our next problem tells us to solve the system by graphing or in your graphing calculator. So I'm going to show you how to do it on both. So I'm going to do it first by graphing. So for my first equation, I can see this is a quadratic, a square function. And I can see that I'm just going to raise it up 2. Now on this, you just cannot be sketching. You got to really make sure it lines up correctly if you're going to use graphing. So I'm going to give myself some more points. You can always add more points if you want to make your graph better. So I've sketched in my parabola. I'm not sure if that's enough or not. I won't know that until I can sketch my second equation. This is an absolute value, and I'll graph these points, and I can see my solution to my system is where they intersect. So I went ahead and extended out my absolute value farther because I want to see where it intersects at both places. So make sure you always extend your function as far as you can to make sure they don't overlap in more than just one place. So my two answers will be -1, 3, and 2, 6. Now let's check these. The way I can check them is I put each one of them into the equation. So first let's check this. So I'd say, and I'm checking -1, 3. -1 squared plus 2 is equal to 3. That's going to be true because 3 is equal to 3. And now I'm going to check my second equation. So 3 is equal to 3, and that one's also true. So I checked my first coordinate for my both equations. Now I'm going to check my second, and I check it, and it also is a solution. So these are my two solutions. But I also wanted to show you how to do a couple other methods. So let's get those graphing calculators out. If I go to my grapher, I'm going to clear anything that's there. and I'm going to enter both equations. My second equation, though, is an absolute value. So I want to show you that function in case you haven't seen that. You're going to hit Math, and then go over to where it says num, N-U-M, and then you can see absolute value is number 1. So it's going to be x plus 4, and then leave the absolute values. And you can see if I were to graph these, let me just use a standard window. I can see they're going to intersect at 2 places. To find those 2 intersections, we're going to hit second trace 5. Okay, and since I only have 2 equations, I can just hit enter, 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 and it will find that first intersection as -1, 3. To find my second intersection, I'm going to say second trace 5. And like we did earlier, I'm going to go along the function using the right or left arrow key until I'm near the other one, and I'm going to hit enter. And so I get 2, 6. So this is very similar to what we did in the last section. Okay, when you have 2 equations, it's not a problem. When you have 3 for like a circle, it can be a little tricky, so be careful, but 2 is pretty standard to what we've done before with just the 3 enters. So when we graph an inequality, we just graph it as if it's an equal sign. We do this when it's linear, we do it when it's quadratic. So let's just graph the inequality, but instead of a less than or equal, we're going to just put an equal there. And let's just draw it first. We can see this is a circle, and we can see that the center of the circle is going to be 5, 7, and our radius, we know, is going to be 5. So I went ahead and graphed my center as 5, 7, and then I went 5 to the right, 5 to the left, 5 down, and 5 up, and I drew my circle. That's my first step. Just graph it as if it's an equal. Now I need to look at the sign. So first of all, if it has an equal sign, this or this, so it's either less than or equal or greater than or equal, we know it's going to be solid. If it doesn't have that equal, then we know it's going to be dashed. So make sure you check that first. In our case, it's going to be solid, so we're okay. Next, we're just going to choose a test point. That's all you need to do for this problem. In other words, you pick 0, 0. That's the best test point. And you put it into your inequality. So I'm going to put in a 0 for x and a 0 for y. And I get 25 is less than or equal to 74. And I ask myself, is that true? Well, yes, that's true. Yes? If it's true, that means that 0, 0 is part of my solution. So since 0, 0 is part of my solution, the region outside the circle is my solution area. If 0, 0 were not part of my solution because it became false, then I would color in the other region, which in this case would be inside the circle. Number 26, we're almost there. Well, number 26 is even easier. It's actually just that we need to recognize that the center of the circle is -7, 6. Remember, for a circle, H and K are both liars. So our center is -6, +6. And our radius, well, r squared is 4, so r would be 2 since it's a distance. So we can graph that. So I graph my center of my circle, and then I'm going to go up 2, to the right 2, back 2, and down 2 from the center. And I can sketch in my circle. And that's all we're looking for. That's fine. And now we're to the end of the test. Woo!